Okay, so agenda for today's event, a quick intro into what we are and what we do and our products. And then we're going to have some introductions onto the product features, and then we're going to have an e-licensing demo, so that will be given by Ross today. Okay. Who are we and what do we do? So Spectrum Centre are spectrum management specialists. We're the unification of the former ATDI offices, and we have offices here in the UK, in London. We have offices in Washington and also in Brazil. Spectrum Section E can be supplied as an off-the-shelf COTS SaaS solution, and essentially that provides the remote engineering, so the technical analysis, remote measurement, and it has an e-licensing capability. And e-licensing is what we're going to focus on. We also have a modified version which meets end user needs. That provides flexibility in a platform which allows us to make modifications really relatively easily to ensure the outputs are personalized to meet end user requirements. In addition, we're still continuing to offer our consultancy services. We offer that across a broad spectrum of technologies and markets, whether that's coexistence studies, interference studies, or even drive tests for not spots. We really do cover quite a wide remit in terms of what we're doing. Okay, so the Spectrum Management Solution. SpectrumE is a web-based browser application. It features, as I said previously, 3 modules: e-licensing, technical analysis, and remote monitoring. The demo that was going to follow will outline some of those key benefits in terms of our e-licensing today, which is going to be our focus. It's worth noting there are a far richer set of features that the tool offers, and these will be covered either on a one-to-one basis if you're interested, or we can do it, we'll be doing them in future webinars. Our webinars are updated on our website, so please do keep an eye on that for any future events. Okay, and really where our customer base is. We have a significant amount of national and regional regulators and spectrum management organisations to date. SpectrumE has been in use for over a decade, and during that time we've worked incredibly hard to build up quite a strong base of customers. If you'd like any more details about any of this, please do reach out to us. We're more than happy to share. I'm going to switch over now to Daniel. Bear with me. Okay, and Daniel's going to pick up in terms of carrying on with our presentations. Over to you, Daniel.
All right, thank you very much, Sarah. And just to confirm, you can all hear me, correct?
We can.
Okay, great. So thank you very much for the introduction, Sarah. I'm going to provide a little bit of an overview on the product, the SpectrumE product line. Kind of describe how we arrived to where we are today with SpectrumE and how this leads into e-licensing and ultimately the purpose of the e-licensing capability and the more holistic view on spectrum management that we've taken in Spectrum Center, and that's ultimately to improve productivity.
Daniel.
So this is, yes, can you hear me?
Yeah,
Hello?
we just can't see your screen, Daniel. Could you share your screen with us?
Oh, I thought I did. Hold on a second. All right, let's see. Is it? No. Here we go. Here we go. Share screen. Click this. It's not letting me start the screen sharing. Don't know why.
Please bear with us, folks. This is what happens when you run things live.
It's not letting me do it.
Okay, not to worry. I'm going to switch it back to me, and I can just go through the presentation with you.
Yeah, my screen. Yeah, all right. So probably better to do that. Don't know why I can't show my screen. But. All right. We were about this. That's correct. So we're talking about ultimately measuring business productivity. We can go to the next slide. So the ITU had defined a spectrum management system. I'll abbreviate that as an SMS as I continue. And I think the first definition was in late 90s. Ultimately, the latest revision of this definition in the ITU SM 1370 was published in about 2013. So roughly every 5 years, they come out with a revised edition of this recommendation. And they define it as an automated spectrum management system that would facilitate national spectrum management and monitoring, coordination among administrations, and exchange of information with the Radio Communication Bureau. And as you read the rest of the document, while some of it is very practical and useful, it is all a little bit, I think, self-serving in the sense that they kind of orient the purpose of a spectrum management system is to ultimately comply with what the ITU needs, which, while is important, and that is obviously something necessary for a spectrum regulator to consider or a spectrum management organization to consider. If this were only or one of even the main reasons to acquire a spectrum management system, there wouldn't be an industry for it. There wouldn't be vendors, commercial vendors. So complying with ITU, while it is something definitely to consider when you acquire a spectrum management system, it isn't just being equipped. It isn't the sole reason. Usually customers have more specific needs and productivity needs that need to be addressed with a spectrum management system that go beyond what the ITU is outlining. And this has really led into a very clearly defined need for e-licensing capability. Go to the next slide. So ensuring requirements and customer needs. So today, these requirements have started to evolve. One particular requirement is the need for improved transparency. Some aspects of this could be highlighted in the following ways. One is web portals. Since I'd say roughly 2009, at least from my experience, I've started to see the need for a web portal to be part of the spectrum management system, to be included in tenders published by spectrum management authorities around the world. I started to see that in Latin America. Actually, one of our first customers in Colombia published that as a requirement. And then it's pretty, it's grown since then. I see that everywhere. Tenders published in the Middle East, even in smaller regulators in the Caribbean and in smaller countries are expecting this kind of capability. So that obviously is kind of changing things. Obviously, that's rooted in the change in technology since the early part of the century. Things have evolved a lot. Being able to manage a spectrum management system entirely through a light client type interface is not such a hurdle anymore. Another kind of requirement that is starting to appear more and more in tenders today is the regulator wanting open technologies and open data formats for the spectrum management system. So while in the, I'd say, early to mid 2000s, there was kind of a push to get equipped with spectrum management systems. Many regulators that acquired those systems ultimately, I think that first round, a lot of them anyways, started to replace them after about 10 years. We actually had a good amount of success replacing some legacy spectrum management systems. Partially, I think a lot of them were acquired from commercial vendors and then maybe combined with custom developments, or in some cases they were custom developments from the beginning. But the regulators found some difficulties. One, with the change of the requirements, made some of those legacy systems difficult to maintain. Some of those organizations eventually became insolvent and couldn't support their products anymore. Also, in the case of specific developments, the regulators had difficulty maintaining those. The architects of those systems didn't stay, and they moved on. They maybe took another job or got promoted, went into management, and so were also very difficult to maintain. So in the next round of tenders that came out, roughly in the late 2000s, early 2000s, was pretty aggressive actually in around that time in the Western Hemisphere. A lot of regulators started to require that things be open, not be closed. They wanted to be able to easily take over the maintenance of the system if in the case something were to happen again, the vendor would become insolvent or anything like that. So that includes everything from the data, such as the network information, the application and licensing data, to be in XML or JSON or be able to support CSVs, the workflow management, which we'll talk about shortly, and even the terrain and clutter. So not to have proprietary formats that can't be reused, trying to move away from that. And also something was to leverage enterprise solutions such as enterprise relational database management systems when appropriate. So you can see I highlighted a bunch of open kind of sources and technologies on the right: Linux, Apache, HTML5. These are some of the components that are involved in developing SpectrumE today. And this is along the lines of what people are looking at when they think of not only web applications, but our kind of software solution in general. Another thing with relation to transparency was detailed documentation on how propagation and interference models are implemented. So more and more customers want to be able to standardize their technical analysis approach and to be able to communicate that to the public, maybe for kind of a pre-analysis purpose, but really ultimately to have a consistent result between the what the applicant or licensee is performing in terms of kind of a pre-analysis step in submission of their application request for Spectrum, and how the regulator would go about doing the analysis. So that's become more and more prevalent and more necessary from a regulatory point of view. So you can go to the next slide. So another one is traceability. So as mentioned, needs for spectrum management systems have kind of extended beyond just being equipped with and compliant with IT requirements. One of these, traceability, is related to workflow management. So time-stamping transition events, time-stamping when things happen. If you can click on the slide, Sarah, see like a highlight here. I have a screenshot of a part of the system here that logs when transition events change. So you can see I have a state column, and in the state column I have a status for that PTP-03, which is also known as under study, versus PTP-02. So each one of those changes gets timestamped, and the user who created or made the modification is also reported in the system. This was always a requirement for a spectrum management system, but tying this into the workflow management is becoming more and more important. This allows a regulator to be able to audit essentially who accesses the system and who does what activities are being performed in the system, and to be able to obtain metrics for those activities and being able to measure performance to some degree. Go to the next slide. Performance is also a requirement that is becoming more clear for the regulators. Amongst many other criteria for performance, multi-core parallel processing is becoming more and more of a need. Being able to handle large numbers of calculations or large numbers of processes in an efficient manner, a kind of a web standard, you could say, where you're not waiting hours, but you're measuring things in matters of minutes or seconds. That's really the performance requirement that is common today in almost all software systems. For example, in SpectrumE, the idea, what it was originally, was to just, with the one instance of the platform, to be able to handle multiple tasks, to be doing technical tasks, to be able to upload large applications with several thousands of links, for example, or stations that need to be assigned, frequencies, or large numbers of tasks that need to be managed concurrently. Does require being able to leverage the processor capabilities to the full extent possible. So that was a major consideration in handling the tool. Also, low overhead. Part of the issue when you're dealing with databases is that the transaction time with the classic enterprise type database solutions, let's say Oracle or SQL Server, is that there's a minimum there just to connect to the database and make the simplest of queries. You have a few, I don't think I have it off the top of my head how long it takes, but it's a few seconds or microseconds, but it's taking enough time that when you start to increase that over time, then you have some difficulties being able to do even initial parts of what a regulator would typically do, which is simply filtering information and getting data out of their system to be able to do some sort of analysis or execute some sort of a process. So what's been common with a lot of vendors in the software space is to offer local database caches and then kind of mitigate when you would have to allow the user to interface with the enterprise database. But for the productivity purposes and for like the day-to-day interaction, working with a local cache has been proven to be the way to go for a lot of our customers. We have some examples below where we're kind of working this way. FCC, Anatel, and Enacom. Anatel being the regulator of Brazil and Enacom being the regulator of Argentina, and obviously FCC the regulator of the United States. So today we have as many 100 concurrent users performing queries over different sizes of databases. Some of these are licensing databases, some are emission databases. You can see the FCC's universal licensing system, probably one of the largest data stores that are out there for pure frequency assignments. The performance time is very short, 1 to 2 seconds, and doing fairly large queries. The Anatel one is a combination cache enterprise, and it's a licensing and emission database. Little longer, but it's still very reasonable. And same with Enacom, very efficient. And we're going to highlight a little bit of that today. But if you want more examples or you want to test this aspect of the platform out, feel free to contact us. We do offer trials on certain aspects of SpectrumE. Continue to the next slide. Okay, reproducibility, this is a big one. This is something that came to us from many customers saying that they need the platform to be able to produce the same results today as it will have to in the future, let's say 10 years from now. And this is because regulators more and more are getting audited. They're being asked to verify how they did a particular analysis or how they approved a particular authorization or a particular request. So being able to centralize everything and being able to reproduce some sort of result or export from the system is becoming a hard requirement. So while client server was always the architecture for spectrum management, it was kind of excused that the engineering part or the technical analysis part could be offloaded to a local PC, because at the time the thinking was that a local PC would be the only thing that would be sufficiently strong enough to handle those kinds of analysis requirements. But today, the idea is to have everything run in a client-server environment. A lot of our customers try to install legacy engineering tools into kind of a virtual environment and have their users remote desktop. So obviously, it was making more sense to take what we mentioned, a more holistic approach, and to have the engineering as well as every other non-technical type of functionality in a client-server architecture. So you don't need to have some sort of remote desktop into a virtual instance of a local legacy PC application, which isn't really making much sense anymore today. So if you want to click on the slide, you'll see highlighted here. We have here the local client server install. That's actually inside the customer's environment. Most, I think, of our customers larger regulators anyways, tend to kind of work this way, or so they'll install our software into their environment. It'll be inside their intranet, their local area network. Commercial cloud is another one that's growing. We do offer SpectrumE in this way. I think this is really contingent on how the database is managed and stored. So if it's publicly available, commercial cloud is an option. However, some government agencies are even working with commercial cloud providers to have government acceptable versions. I think Microsoft Azure, Amazon, etc., cable and wireless, they have government secure options for their commercial cloud services. So that is growing, but it's not taken off totally yet. And then there's hybrid cloud, which is a combination of the two, where part of the system would be localized and then part of the system would be calling a commercial cloud. So a lot of times web services are leveraged there. Sometimes a customer may make a custom system, and they'll simply call, let's say, our web service or our API to execute a particular function, and we'll pay for that function. Maybe it could be a coverage, or it can be an interference analysis, or it could be something like that. So we have a lot of customers looking at the hybrid cloud. Go ahead, click on the next thing. So client server, that's still popular, but hybrid cloud is also growing. One last thing, I'll go back to the previous slide real quick. I wanted to mention was this is also leading into the avoidance of secret sauce approaches. So that has been historically kind of a way a lot of vendors in this space have provided their capabilities, is they don't really document, or they don't really expose how they're performing a particular analysis. So that in order to reproduce results, let's say for the purposes of billing, if someone is doing a population coverage calculation, they need to know exactly how that was done, what models were used, and how the tool is interpreting the pixels even that are being covered, because that can obviously have a big impact if that's used as a reference for creating an invoice. So when the tool is doing a little too much secret sauce, it puts the customer at a kind of a vulnerable position where they're dependent on that vendor, and they don't really know how that vendor was calculating the population coverage. And if anything were to happen to that vendor, they have a little bit of a single point of failure, and that can cause obviously issues. So go to the next slide. And integration support, modern integration support. So more and more customers are requiring the need for a fully documented and mature API and support for enterprise service bus solutions. We do offer that by way of RESTful web services. We have here a screenshot of our API, a typical function that a lot of our customers call in our API, the get coverage function. So we have customers that maybe don't really want to use the rest of the system, but are very interested in certain aspects. It could be our business rule engine, or it could be our technical analysis features. So they'll simply pay to access those functions and then work inside of their hood, so to speak. So that it also ties into the hybrid cloud approach that I mentioned earlier. So these are kind of things that aren't really covered by the ITU, but they're things that are becoming more and more important for the delivery of an SMS. And we've considered over the last decade or so in developing our solution, SpectrumE. So go to the next slide. So here's some examples of measured business productivity improvement with our solution. I'm using a case of the what we call Mosaico system. That's essentially the SpectrumE system, rebaptized as Mosaico and by the Brazilian regulator. So you have here a graph, and on the x-axis you have months. Can you move, so you have a little bit of a, I think, a window peeking in to the left y-axis here, but well, we'll go ahead and go there. And on the y-axis you have two ways to interpret that. You have also the number of technical studies in blue that are performed in month to month, and the number of days needed to complete the analysis, which is what the red curve here is representing. So this acquisition by this customer was in time for some world events that occurred in Brazil in 2013 and 2016, particularly the World Cup and the Summer Games, the Summer Olympics. And one of the needs of the customer, amongst many, was to be able to support the need for handling of temporary use of Spectrum applications during these world events that Brazil anticipated would kind of put a heavy amount of demand on their personnel. So they were never really used to handling events of that magnitude. The largest they would handle would be Formula One and Carnival, and they already had a little bit of difficulty with those. One of their issues was that they would subcontract the work out to part-time consultants during those periods, and the consultants would kind of do their own thing in terms of technical analysis and processing the applications. And they had difficulty basically, getting consistent results, basically, you could say, from the different individuals, the analysts that were involved with processing their applications. So one of the things they wanted to do is standardize that. Have a standardized methodology, have that all hosted in a central kind of environment, and then have people be able to reproduce the same result and have some efficiency. So ultimately, the benefit was that the processing of the application and the technical analysis as well got reduced from taking a few weeks per application to down to only 9 minutes average time. And they didn't really need to have any more part-time consultants. They were able to complete the work with 3 to 5 Anatel employees. And towards the end, they were handling this workload, high workload with very few analysts. Obviously, this doesn't eliminate the need for engineers. They have their own engineers, but those engineers are focused on other tasks, and they're able to become overall more efficient and reproducible with the results. So go to the next slide. So another example here is Anacom Argentina. So they had a spectrum management system they had acquired in the, I think, mid-early 2000s that ultimately was never really well put into production. It was an IT compliant system, but they eventually discarded it. They went about creating a number of discrete systems to do this, their spectrum management work, but ultimately had a little bit of difficulty maintaining those systems. They weren't well integrated with each other. The architects eventually left, all that sort of typical story. So they eventually needed to replace all of that and integrate everything into one system. They called it Hertz. It is SpectrumE, but they've given it again, baptized it with their own custom name, which is no problem for us. And while in the past they were still kind of doing this by hand through paper applications, this licensing process management, today they're able to do it with the system. And while it was taking them weeks to process an application, today they're processing about 90,000 a year of the following types: new, modifications, suppressions, cancellations for radio spectrum and equipment type approval, antenna site registration, and more. So roughly 80 radio service categorizations were implemented, and today the system is supporting approximately 24,000 internal and external users. Majority of them are external, mostly type approval and amateur radio services. We coded about 19,000 workflow paths into the system. One brief thing that I wanted to mention is that we did consult while implementing or developing our e-licensing capability with business process management vendors. There's several of those that some of you may be aware of. And it was interesting because we wanted to know how they would charge for a case like this, like Anacom, where there's 19,000 workflows to code into the system. That was not even registering on their scale. It was so small. For them, these vendors are used to working with, banks and large other types of enterprises where they're dealing with at least 100,000 workflows. And really, they were kind of more selling a service than a product. And their role was to optimize that sort of activity. And so spectrum management, we thought this was kind of a heavy requirement. We learned that spectrum management, again, was in this weird space where it has a need for workflow management. It's not sufficiently large enough to attract the typical vendors in the space. So that's a little interesting piece of information to know. So that did make us go back to revisit the situation and kind of put together our own solution. So go to the next slide. So going to e-licensing, this is what eventually led to us developing our e-licensing solution. We'll go over a little bit of how this works, and then we'll go into the product demo. Running a little late on time, but I think we'll catch up soon. So go to the next slide. So typical license application workflow. So some of you that attended the last webinar probably have seen this slide before, but it's a kind of a simple example, very simplified example of what we mean by e-licensing. It's enabling a user external to the organization, like a citizen or a business user, to interface with the regulator, the government, and to have this kind of interaction. And obviously in the case of spectrum management, is typically for authorization of licenses for spectrum usage or equipment type approval or something like this. So you have, here I've highlighted in the diagram typical steps. Now, this is not standardized. No, this is not how all regulators work. Some regulators do things differently. Some require payment up front to process the application. Some do it at the end. So this is obviously have to be very adaptable, and we accommodate these kinds of differences as customer explains them to us. The e-licensing module, each step in the e-licensing process is typically connecting to our business rule engine, which kind of validates that the application is properly configured or prepared to go to the next step. We had to be very flexible here because some customers may allow for, let's say, some corrections to be made. They may allow for the application to be returned to some extent to the applicant so they can make a correction rather than outright rejecting them. So simply to say the workflow management mechanism that we had to implement couldn't be fixed. It had to be, or it could be fixed if the customer required, but we had to be very flexible if we were to offer it as a commercial solution. So today there's about 300 business rules in the business rule engine that's included in the commercial version of SpectrumE, and it's also part of our API. So both the workflows and the business rule engine are, of course, highly customizable. So if customers want to add in their own rules, we work with them on that. So go to the next slide. Workflow management. Today, there are two dominant workflow protocols supported by business process management software vendors. So one is BPMN, or Business Process Model and Notation, and the second is State Chart XML, State Machine Notation for Control Abstractions. So we aren't necessarily tied to either one of these, but we did kind of lean toward SCXML because of its flexibility. On the right, you have an example of a typical sub-process workflow. So this example here on the, you can't see it very clearly because it's such a large diagram, didn't even fit on the slide. But on the left-hand side, you have kind of these rows. Those are what we call lanes, and those would represent maybe a user. And the bubbles inside represent pools, and there's transition events associated to each one of those pools. So as someone starts the process, it goes to maybe a deciding event, a transition event that can then relate to another sub-process, possibly, simply to say that the bubbles inside can represent their own workflows. So as you can imagine, this can get very complicated at some point. But of course, it depends on how the user wants to decide what step to go. So a full heavy e-licensing demonstration would take, actually we timed it, it's around 4 hours. So we're not going to do that today. We're going to do a much more simplified version, scaled down. And so just to give you guys a flavor and an understanding of how this works, but obviously we have no limitations. Our implementations are real enterprise implementations for customers in this space. Yeah, we're doing something like 20,000, 30,000 workflows, something like that, or more. Not as much as big banks and stuff, but very heavy, and definitely the system has to be capable of handling that much. Let's go to the next slide. Services supported, we have no limitation. I just listed here what's typically listed by the ITU. So we've got aeronautical, amateur, all the broadcast services, AM, FM, analog TV, analog and digital TV and sound, cellular, maritime, mobile, land mobile, private mobile service, fixed services, point-to-point, point-to-multipoint, satellite spatial services. The categorizations can be customized as well. Customers may have their own way of defining things. Here's an example of a customer where they kind of organize things their own way. They actually have about 80 radio service categorizations, and we simply adapted ourselves to meet their need. So go to the next slide. So request type supported. Again, there's no practical limit here. So we can highlight just about any kind of request type. But today we're going to focus on the first three on this list: external user registration, organization registration, and new license request. So click on there and we'll just highlight that point. The modification, renewal, suppression, cancellation, equipment type approval, we won't get to it simply due to time constraints. If you want to know more about that, please follow up with us and we can tell you how we would handle those kinds of requests. Go to the next slide. and I think it's just a continuation of more types of requests that we can support. And this is just some examples of what we've done for other customers in the past. Obviously, we mentioned temporary use of Spectrum, license transfers, entity name changes, equipment and site registrations, payment plan requests. And there's no real limitation, like I said, for the last slide. Additional features, again, things that we won't be able to cover today. We're already running about 10 minutes late. So IT coordination, generation of WSFAC compliant electronic files, we can support. We have documentation on that. Uploading document attachments. We're not going to highlight that today, simply partially because of time and partially just because we're trying to do kind of a pared down demonstration, but control of document attachments, formats, things like this. This is all part of the business rule engine, and the system, of course, e-licensing does need to be able to do that. So it can be supported. Notification management, we're not, because the demo is going to be run offline. You're not going to see the email notification capability, but you can imagine as things are changing, as the statuses of the application change, notifications are being sent out typically to the users, particularly the external user. You will see some on-screen alerts, and localization system is UTF support, so language support, Romantic languages, Chinese, etc., Hebrew, Arabic, all supported. Also, and for Middle Eastern customers, right to left orientation is also supported. Okay, with that, I think we can begin the product demo.
Thank you for that, Daniel. We're just switching over now to Ross, who's going to take over on the product demo. Over to you, Ross.
Yep, thanks very much, Sarah. Let me just confirm that you can see my screen, and I'll kick off the e-licensing demo for you.
Yeah, we can, thank you.
That's perfect. Excellent. So I'm going to do a quick demonstration of the e-licensing software. So just to take you through what I'm going to show you today, I've got a couple of quick slides that we'll go through, and then we'll get straight into the demo. So first of all, we're going to show how the external business user authenticates with the system, signs up for a new account, and associates himself with an organization. We'll then, from that new user account that we've created, send a license request to the Spectrum regulator, requesting, and in this example, we're going to look at a point-to-point link, point-to-point microwave link. Then we'll step in to the regulator or Spectrum manager's point of view, receive that request, review it, and make the final determination whether to allow or reject that application. And then finally, we'll generate the license certificate for the assignment and send that out to the user. So briefly, just to kind of show you a couple of examples as we go through. So we've got our user registration sign-up forms. So these can include any information that the Spectrum manager or regulator requires. And these are all customizable, and in our demo, we'll be using a kind of cut down version of this. Again, the license application request form, that can be edited to suit the Spectrum manager and then submitted by the user, by the external user for that. We'll look at briefly some of the technical analysis and the administrative analysis tools as well. And again, this is not a full technical analysis demo. Future webinars will contain a bit more information than this. And then we'll look at the legal part of the license and the technical part of the license, how those can be customized and then sent out to the user as well. So without any further ado, I'll step into SpectrumE. So again, SpectrumE, as Daniel mentioned, it's a web application. And from the external user's point of view, the first thing that we'll do is request access to the system. So what we'll do is we'll put in some user information. We'll request access to the e-licensing module. At this stage, it will ask us what organization. We possibly don't know that, and that could be left blank, but send that off. So at the moment, the system's not connected to the email server properly, so because it's been running the local host, so we'll get a failed notification here that the email hasn't been sent. But what's happened in the background is that notification, the access request, has been sent over to the internal user. So we've sent off our access request, and now we'll log in as the internal Spectrum manager. We'll log into their user database, data store, and here we can see the requests from users. So we've seen our request from the user that's been created, been sent. We can pick that up, and then we can grant access to that user.
Just one quick interruption here, Ross.
Yes,
just
sure.
wanted to interject on this one point. So what we're showing here is not a requirement for using the system. It is a solution that we offer with the e-licensing system, because while roughly half the time the regulator or the enterprise has some sort of user registration capability and another system for that purpose, I'd say roughly half the time they don't. So by default, we implemented some sort of a user registration feature in the tool. One of the questions that was obviously emanated from that was, well, how does the regulator have the ability to curate all these accesses? Are they going to have to constantly interface with the external users all the time? And so one simple solution was say, well, we'll just put timers, and we'll put the onus on the external user. So that's kind of a part of the story of the e-licensing, is to put the onus on the external users or the public to re-register themselves, authenticate themselves on a regular basis, as well as in terms of the whole concept of submitting data. It's no longer on the regulator to have to fat finger in the customer's application information, but it becomes more the job of the external user. Go ahead and continue, Russ.
Yeah, that's a good way to increase the efficiency of the users as well. So we'll allow this user access. I've set the timer for 2 weeks. And again, this will process the request, send out information to that user to log in and be able to reset their password. So once that's done, we'll be able to check our user database, and we can see that that user's been created. So there's a couple of extra steps for setting up the user, which I'll skip over just for the purposes of time here. But we'll continue the demo with this SC legal rep email address and continue submitting and connecting to an organization from there. So once the account's been set up, we can log in as our legal representative. And here we can see that we get a limited number of menu items, just including some of the e-licensing features that we're interested in just now. So at the moment, we're able to join an organization, we can create a new organization. So from our registered organizations page, we can see that there's a organization already associated with this login, but we can also request to register a new organization, which we'll do here. We can add additional. We also have the validation features to catch any contact information that hasn't been filled in, and that saves the internal user time when reading through the applications. So once we've created that request, the next thing we'll want to do is submit that to the regulator. So in the draft state at the moment, once we're happy with it, if we need to do any further edits, we can go back there. We'll submit that, accept any terms and conditions, and once any integrated checks are done that are required, maybe searching a government database, a web service check, for instance, we can accept that. And again, if any payment that can be integrated anywhere through the process as to whatever stage the regulator requires. So now we've submitted the application for the organization to be connected. What we'll do again is just flip back to the internal Spectrum manager, and then we'll approve that application. So we can see the request here from our SC legal rep. We've set the ID to 5555, so that's just associated with the name of the user. So we can approve this organisation, and now that goes into our licensed organisations that are able to do business with the Spectrum Manager from this stage. So our next stage that we're going to do is submit the point-to-point application to the regulator. So we'll log back in as our legal rep. We understand that we're working on behalf of the Raymond's Rays organisation. So this allows users to work on behalf of multiple organisations when they're submitting licenses on their behalf. So we'll look at their point-to-point links. As we can see here, we've got a couple of requests that have been set up already. What we'll do just for this demo is just delete these and start afresh. Create a new point-to-point link. So as we go through, we can fill in the details of our location for our link. The terrain elevation, once we go to the map, will be pulled in automatically from the digital terrain model that we have. We can confirm the location using our Google Maps. Able to view the satellite just to confirm that the coordinate that we've put in matches up with the exact location for the records that we're submitting to the Spectrum Manager. So if we apply that, we can close, and that will automatically update our map. So for this example, we'll have a look at something in the 5 gigahertz fixed link range. We've got a couple of bits of information, and also the equipment type can be linked to a type approved database, and that would show or allow the users to only submit information that's been approved by the regulator for use in. We'll add some more. We'll just check this is popped up at the right location. I'm happy. Complete the form, and we'll look for a 28 megahertz channel. Again, we can validate, and if any fields are out of bounds, it will flag up. Obviously, this can be set as to mandatory fields or fields within a specific bound, so you can look. You can add latitude and longitude within a range. So if the submitted coordinates fall outside a certain range set by the operator, the regulator, it would flag up and notify the user at this stage. But it seems to have passed that check, so we're quite happy with that. Now we're ready to submit that to the regulator. So all the time, links are not always individually populated within the form. So we also have the option to bulk upload a number of links by using the add object list. So we have the format info, which describes within the CSV file that we can upload the fields that are required, and then comment about the information that's required within each field. So of importance is the licensee ID, which is required to match the licensee ID of the user that's uploading that file. And we'll come to that just as I show you some of the examples. So what we're interested in doing is here we have a list of a CSV file. So we've got our user ID and then the technical information about the rest of the sites. What we can do is try and upload this. So notice here that the licensee ID doesn't match the 5555 licensee ID of our current user that we're logged in as. When I go to validate, we get an error message saying it must match the user. We also have other validation steps. Bear with me, this is playing catch up. So Google managed to save it. So we've got another example where a number of fields have been left out, missing, or out of the valid range. So when we validate this, we can see that the number of checks were performed across all the cells that we had a limit or a range on, and then we get information about latitudes, antenna heights that are out of range. So again, this flags up to the user that the information that they're about to submit isn't correct. We can go away and correct that. Revalidate, and then we're able to import that. We can now see that the 27 records that were in that file have been imported, and we can go back and see we've now got 28 records, the one we put in manually, and the additional 27 that we imported. So once we're happy with all our records, what we want to do now is submit these. This example, we'll select a couple and send them over. Again, we have the terms and conditions, and this can be integrated with any parts of the business rules or the workflows that the regulator uses. We'll accept that, and now these have went into the pending state. So that's been set. What we'll do now is point-to-point link store, and we're able to see that these so looking at the licenses for each one as they're in the pending state, we have a number of different options. So we can cancel the request, which takes this off our list, records it within the database, and then sends it back to the user. So we can do that. That will take it off our list. We can pick up the request. So either as a team leader, we can pick up and send this over to some of our team members, so we can manage the workload there, which kind of increases the productivity of the staff, as we can split it out amongst the team. So when we pick it up, it becomes under study. And again, here we have the ability to reject that application. So maybe there's important details that are missing. We can reject that application and say there was no antenna height. We can send a message back to the user and they'll be notified and it will be taken off our list. And once again, just to reiterate, the date created and timestamps are placed on the objects as they're moved about within the workflows. So what we're interested in doing now is creating, doing some technical analysis on the application. So in order to do that, we can send it to map. And so what that will do is allow it to add it to our network. Oops,
don't forget to pick it up. Gotta pick it up first.
Oh, right, yep, sorry. Yep, so pick it up, it goes under study. Now we can send that to map. So we'll send this as a microwave link. Here, we can see that that's appeared on our map now. So we've got full UK mapping data. We can view this to zoom in on it just by selecting the microwave link that we're interested in, map selected object, and we can see where that link exists. So one of the first analysis that we could do is look at the path profile between the 2 points of that link, just to see if there's any problems that we might reject it at this stage for. And for this one, it looks like we've got good line of sight, so we can continue to the next steps and try and assign that frequency. We've got the technical for any specific models that the user requires. Next of all, what we're interested in is trying to assign a frequency. So in order to do that, what we'll need is to have a look at the existing electromagnetic environment. So there's a couple of ways that we can do this, and we're able to integrate with databases of existing links. We've created a link into the wireless telegraphy register. So that shows all the emissions in the UK, obviously quite a high number. We've sifted that down by only microwave links. And then again, we're able to filter this further by either center, latitude and longitude and a radius around it using a geo filter. Or in this instance, we're interested in the frequencies if we're looking to assign a search that band. And then that's filtered the 20,000 records into just under 1,000 records at the various operators. What we'll do is we'll select all of these and then again send them to map, so we've got our existing environment. Because they're the incumbents, we'll use it as the existing microwave network. And you can see very quick processing. And now what we've done within our area of interest, but links with the association that's contained within that database, we're able to import into our environment to do our testing. So what we want to do here, just the next step of our technical analysis, is to highlight any suitable frequencies. And what we're going to do here, so once we've imported, there's just a couple of quick their original database. So what I'll do is I'll just shift over to a different network, and I've just made a couple of quick edits to this, just so this is based on a TIA spec, a pass on the flat Earth model to identify if there's any channels that are free from interference. The plan that we're going to scan is the 7.5 gigahertz channel plan and looking at 28 megahertz bandwidth frequencies. We're interested as our incumbents as existing microwave links. So as we run this will identify if there's any channels that are free or causing interference, and then produce a report that shows the number of interferers to each of the stations. So with that kind of nationwide set of data, we've managed to quickly identify a number of channels that we have a pass, and again a number where there's a potential for fail. So again at this stage, this is looking at a flat Earth, so the terrain is not being taken into account. So it's likely that some of these fails would become passes if we do a further investigation. So I'll quickly look and try and identify the channels. So that's number 3 and number 3 for the A end and the B end of the link. They look fine. So what we can do is update our link with these new frequencies, modify, and also we're able to, because we're in a browser based, we're able to have multiple screens open during analysis and be able to quickly switch back and forward and refer to them as well. So once we've assigned the frequency, what we'll do is we'll look at an interference study to the network or to another network. So from our potential link, we're looking at the victims being the existing microwave link. And again, this process runs, and this is where we pull out a bit more technical detail in terms of C to I's and power received from each of the links in a very quick, efficient manner. So we can see that there's no potential interference on the channel that we've selected. So we're happy to go ahead as the regulator and assign that channel. So once we're happy that our chosen frequency is available, what we can do is go back to our licensing data store. We can have a look at the request for our point-to-point link. Edit this. We can update the frequency to our chosen frequency. Update any further technical details that we need to, but then we're able to approve this assignment and send it to the licensed box. We approve it, and now it sits at the bottom. Licensed. This will be our final stage to generate the certificate and be able to send it to user. So generally the certificates will be customized templates by the user, and they can be edited within our within the tools, including legal documentation, and we also have the ability on an individual basis to further edit licenses as well. So we can generate the certificate, that will go away in process, and then prepare a PDF certificate. So this could include any legal documentation, it could just be the technical analysis and the technical assignment. So we've prepared our link. We have any information that we need by the regulator. Also a nice wee feature is we've integrated QR codes. So if the operator is required by the regulator to keep information at the sites where the installation is, and the regulator, if they're doing surveys, they can come up with their phone, scan the QR code, and then have a link to the current licensing database online, and be able to look at the information there. So that's went through that quite quickly, but hopefully it gives you an idea of the licensing process from start to finish, how SpectrumE offers the integration of the e-licensing and the technical analysis. And I'll pass you over back to Sarah, I think, and if we've got any questions we can answer those.